All right, this is question 7 from section B. Now, for section B, you should be writing your answers on a separate sheet of paper. I'm not going to here, I'm going to write on here just simply so you can see the questions and see my answers at the same time. But you would be writing this on just a plain piece of paper. All right, so we've got function y equals 4 minus x over x plus 2, and we need to write down these things. I'd like to draw your attention to these instructions. A lot of people lost marks here because they didn't put coordinates or they didn't put things as equations. So this is a reciprocal function. It's going to look something like this-ish, but if I have to sketch it, I'll do a better sketch than that. Okay, the y-intercept, this is when x is 0. So when x is 0, y equals 4 minus 0 over 0 plus 2. So 4 over 2, which is 2. So my coordinates, 0, 2. The coordinates of the x-intercept, all right, x-intercepts happen when y is 0. So if y is 0, then 4 minus x over x plus 2 is 0, which actually just means the numerator is 0 if you multiply up. So 4 minus x is 0, x is going to be 4. So the coordinates are 4, 0. Now, the equation of the vertical asymptote. Here we're looking for equation of a vertical line. So all vertical lines have the equation x equals a number. So we're looking for a value of x that won't have any corresponding y value. This is going to come about when our denominator is 0. Okay, we can never divide by 0, so when we have x plus 2 equal to 0, y will be undefined, which gives us the value x equals minus 2. We can think of it as a value, but it's also the equation of a line. And the horizontal asymptote, every horizontal asymptote has an equation of the form y equals a constant. So here we're thinking about the limits. Our function will be approaching this as x gets very, very big or as x gets very, very small. So if I think about x getting very large, here, 4 minus x, the 4 becomes insignificant compared to the value of x, and on the bottom the 2 becomes insignificant compared to the value of x. So I get minus, say, 1,000,000 over 1,000,000, that's going to cancel out to be minus 1. Okay, so there we're thinking about limits. We're finding the value that y approaches as x tends to infinity. Okay, so there's our equation. All right, hence or otherwise, sketch the graph of this and clearly indicate on your sketch all your answers from part A. So I know roughly what it's going to look like, but let's put in the asymptotes first. So x equals minus 2. And because I have to clearly indicate them, I need to label them. And y equals minus 1. I'm going to have a y-intercept, or my graph going through the point 0, 2, which will be kind of there, and the point 4, 0, which will be kind of there. So I can see that my graph will go over here. Now I need to make it look like it's approaching the asymptote. I need to extend that asymptote a bit more so it can look like it's going towards it. It's a bit easier to do it down here. So your sketch should not look as if it's kind of going back on itself. Like my one up here is terrible because it kind of curves back on itself. It needs to be heading towards the asymptote, but never touching it. And because it says clearly indicate on your sketch, I've already got my 2 equations written down, but I do need to put the coordinates on that sketch as well. All right, next part. Consider the function f of x is log base 4 of this. Using your answer to part A or otherwise write down the domain of f of x. All right, if it says using your answer to part A, we will use the answer to part A because we want to make our lives as easy as possible. So really important to notice here is that we're not writing down the domain of this function. This function is this one, and f of x is a different one. It's log base 4 of that. What do we know about log? Well, we know you can only take log of a positive number. So we need 4 minus x over x plus 2 to be positive. Okay, well, we could solve that as an inequality algebraically, or we could use our graph to say, okay, well, this is the graph of 4 minus x over x plus 2. When is it positive? When is it positive? When is it above the x-axis? Well, I can see here that it's positive for this bit here. I'll just put my highlighter on there. This is the section of the graph that's positive. Well, what x values does that apply to? Well, it's when x is less than 4, but more than minus 2. So this is the domain of x that's going to give me a positive value of this, which means I can do log of it. It's not possible to do log of a negative number. That is definitely the easiest way to do it using the graph. I said you can solve it algebraically. It gets complicated because if we're multiplying up, remember if you multiply or divide an inequality by a negative number, you need to switch the inequality sign, and we don't know whether x plus 2 is positive or negative. It depends whether x is greater than or less than minus 2. So you can do it, but you'd have to be very careful about stating if x is greater than minus 2, then it's positive. So when we multiply up, we get 4 minus x is greater than 0. I'm not going to go into that now. I'm just going to tell you to use part A. All right, next bit. Show that f of x, this thing, is k over ln of 2, brackets ln of 4 minus x minus ln of x plus 2, clearly stating the value of k. All right, so essentially we're going to have to transform this into this using log rules. I'm going to use this space down here to do it. So the first log rule that I'm going to use is that if I've got log base A of B, that is log, I can pick a new base C of B over log base C of X. This is our change of base rule. Now specifically I'm going to choose log base E, also known as ln or ln. So taking log base 4 of 4 minus x over x plus 2, I'm going to say that's log base E of 4 minus x over x plus 2 over log base E of 4. Next, I'm going to use another log rule to get rid of this division bit. So we know that log of A over B is log of A minus log of B. Now, I really should put a base in here, but it works for any base. I could put log base C in there, just to be clear. So this means, and actually on this step, I'm also going to start writing log base E as ln. So this is ln 4 minus x minus ln of x plus 2 over ln of 4. Right, let's pause. Let's have a look at how it compares to what I want. Well, that bit's looking pretty good. And then I've got divided by ln of 4. What I want is multiplied by k over ln of 2. So I need to transform 1 over ln of 4 into k over ln of 2. So how can I rewrite ln of 4 as ln of 2? Well, we know that log of a to the power b is b times log of a. This is, I'm just going to put this off to the side actually. So ln of 2 squared, which is ln of 4, would be 2 ln of 2. I'm trying to write out each step because it is a show that question, which means I need to be clear. So this is 2 ln 2. Now comparing that, it's almost the same. I've just got, where this is k, I've got 2 at the bottom, which means k is either I'm going to write it as this. 1 over 2 ln 2, where this is my value of k. So k equals a half, or you could write it as 0.5 in the numerator. I think that's why the question says clearly stating the value of k. So it's clear that we know what's going on. Okay, that one's done. And for the last part, we've got hence or otherwise find an expression for f dashed of x. So we're differentiating. I've got a function that's got a constant here, and then it's ln and ln. So what are my rules for differentiating ln? Well, remember, if f of x is ln of a function, I'm not going to use f of x again, I'll use g of x, then f dashed of x is g dashed of x over g of x. So when you differentiate something with ln in, your answer doesn't have ln in anymore. Okay, it's just got the function that was there on the denominator and the derivative of that function as the numerator. Let's get a plain bit of paper to do this. Okay, so here my function is 1 over 2 ln 2 of ln 4 minus x ln of x plus 2. Now, I know we've got ln here and ln here. These are functions because there's x. This is just a constant because ln of 2 is just a number. So when I do my derivative, I'm going to keep my constant the same there, and I'm going to differentiate each of these functions separately. So I'm focusing on 4 minus x. That's going to go at the bottom, and then the derivative of 4 minus x at the top, which is just minus 1. Minus, now I'm focusing on this one, x plus 2 is going to go on the bottom, and then the derivative of x plus 2 on the top. So it just says find an expression, so I'm going to leave it like that. We could put this over a common denominator, we could sort out some of these negatives, but I think it's fine to leave it as that. All done.